Ali Atira binti Muhammad Ayu. My metric number is 14 DTK20F 2023. I want to present about definition of the stationary point. What is stationary? Stationary is a point of a function fx is a point where the derivative of fx is equal to 0. This point are called stationary because at this point the function is neither increasing nor decreasing. There are three types of stationary point, which is maximum point, minimum point, and point of inflection. The equation of gradient is y equal fx. Firstly is maximum point. Maximum point is considered what happens to the gradient at the maximum point. It is positive just before the maximum point, 0 at the maximum point, then negative just after the maximum. The value of dy of dx is decreasing, so the rate of change of dy of dx with respect to x is negative. D power of 2y of dx power of 2 is positive. Next is minimum point. Just before minimum point, the gradient is negative. At the minimum, the gradient is 0, and after the minimum point is positive. The value of dy of dx is increasing, so the rate of change of dy of dx with respect to x is positive. Power of 2 y of dx power of 2 is positive. Lastly is point of inflection. At some points, dy of dx equals 0 and d power of 2y of dx power of 2 equals 0. Two such points are in a sketch. They are called point of inflection. That d power of 2 y of dx power of 2 is also 0 at some maximum and minimum point. To find the type of stationary point, consider the gradient at each side of it.
Hi, my name is Nishalini, daughter of Jyoti. My matrix number is 14 DPK 20F 2021. Now, let's have a look on some example questions on maximum point, minimum point and inflection point. The question number 1 is, given y equals to 4x minus x squared. First, we need to differentiate this equation. When we differentiate this equation, we will get dy over dx is equals to 4 minus 2x. As we know, the dy over dx for stationary point is equals to 0. So, to find the value of x, we will get the equation 4 minus 2x is equals to 0. So, we will get the value of x is equals to 2. Now, we need to substitute this value of x into the given equation. So, the equation will be y equals to 4 multiplied by 2 minus 2 squared. We will get the answer 4. So, the stationary point for this equation is 2, 4. Now, we need to find the stationary point is maximum, minimum or inflection. To find it, we need to differentiate the equation again. When we differentiate the equation again, we will get negative 2. Negative 2 is lower than 0, so it is maximum point. Now we can draw the graph. When we draw the graph, the curve will be facing up like this. Now let's move on to the question number 2. Given y equals to 2 plus 3x squared minus x cubed. First, we need to differentiate this equation. So dy over dx is equals to 6x minus 3x squared. The dy over dx for stationary point is equals to 0. So the equation will be 6x minus 3x squared equals to 0. So we need to use the calculator to find the value of x. We will get 2 value of x. The first value of x is 0 and the second is 2. Now we need to substitute this value of x into the equation given. So the first equation to find value of y1 is equals to 2 plus 3 multiplied by 0 square minus 0 cube. So we will get the answer 2. So the value of y1 is equals to 2. The second equation will be 2 plus 3 multiplied by 2 square minus 2 cube. So we will get answer 6. The stationary point for this equation will be 0, 2 and 2, 6. To find the stationary point, whether it's maximum, minimum or infraction, we need to differentiate the equation again. When we differentiate the equation again, we will get the answer 6 minus 6x. First, we need to substitute the value of x1 into 6 minus 6x. So, we will get the answer 6. 6 is greater than 0. So, the stationary point 0, 2 is minimum. Secondly, we need to substitute x2 into 6 minus 6x. We will get the answer negative 6. Negative 6 is lower than 0. So the stationary point 2, 6 is maximum point. Now we can draw the graph. The curve at stationary point 0, 2 will be facing down, and the curve at stationary point 2, 6 is facing up.
Assalamualaikum and hi. First of all, I would like to introduce myself. My name is Nino Sabrina binti Paiman. My metric number is 14DTK20F2005. Rate of change. The gradient function dy of dx of a curve measure the rate at which the curve increase or decrease. Differentiation allows us to find rate of change. For example, it allows us to find the rate of change of velocity with respect to time, which is acceleration. It also allows us to find the rate of change of x with respect to y, which on a graph of y against x is the gradient of the curve. If y equal f bracket x, so dy of dx is rate of change y respect to x. Chain rule method used to express the rate of change. Dy of dx equal dy of dt multiply dt of dx. It is related with parametric equation. The positive value for dy of dx is the rate of increase for y respect x. The negative value for dy of dx is the rate of decrease for y respect to x.
Assalamualaikum. My name is Nur Sarah Saifri binti Nur Saiful with my matrix number 14DTK20F2041, and I will explain about the example of rate of change. To better understand the concept of rate of change, let's dive into the situation. So, the situation is, the surface area of sphere is A equal to 4 pi r squared. The radius of sphere is increasing at a constant rate of 0.3 cm per second. Find the rate of increasing of the surface area of the sphere when its radius is 9 cm. First, we need to express the following statement in rate of change notation. The radius of the sphere is increasing at a constant rate of 0.3 cm per second, so it will be dr over dt equal to 0.3 cm per second. Next, we will find the rate of increasing of the surface area of the sphere when its radius is 9 cm. First thing we need to do is express the chain rule. In this situation, we use dA over dt equal to dA over dr times by dr over dt because we need to find the surface area. Next, given area equal to pi r squared, we must differentiate this equation to get dA over dr. Brings 2 forward and multiply by 4. By the square root above, we have to subtract it by 1 and we get the result of dA over dr equal to 8 pi r. After getting the value of dA over dr, enter the value that have been given into the chain rule that we have expressed earlier. dA over dt equal to dA over dr times dr over dt. So the value of dA over dr is equal to 8 pi r, and multiplied with the value of dr over dt is 0.3. Then substitute the value of radius equal to 9, and we will get the final result of dA over dt equal to 67.86 cm squared per second. I hope this situation will help all of you to understand better in rate of change.